Hi students, welcome you all to AEE Maths Mantra YouTube channel. So in this video, I am going to talk about partial fractions. So see my dear students, here you may prepare for your board exams, you may prepare for your JEE mains exams or any competitive exams. First, you have to understand the concept. Next, using that concepts, you have to develop the tricks. Okay. So here in integration of partial fractions, which is one of your integration method, you have to understand the concepts first, then you have to go for the tricks. Okay, so as you all know, in integration we have three methods: integration by substitution, integration by partial fractions, and integration by parts. Okay, so now let us start integration by partial fraction. So to go for integration by partial fractions, first you must know where to use this integration by partial fractions. So in the functions of the type p of x divided by q of x, that is called fractional function. That's called fractional function. Okay, so in this fractional function you have to use partial fraction. That means then what are the conditions? See here, what are the conditions? What are the conditions for partial fraction? For partial fraction. Okay, first we must understand the conditions of partial fractions. Clear? That is, first one, it should be proper fraction. First one is it should be proper fraction. What is the meaning of proper fraction? That is your sub point 1. The degree of p of x must be lesser than the degree of p of x must be lesser than the degree of q of x. The degree of p of x must be lesser than the degree of q of x. So see here, p of x by q of x is called partial fraction. Clear? So now if I write x minus 1 divided by x square plus 1, so here this is proper fraction. This is proper fraction because you can see that the degree means the highest power of the given polynomial. See, the highest power of the given polynomial is 2. Here it is 1. Okay, so that is called degree. So degree of x square plus 1, that means the degree of here, the degree of q of x is greater than degree of p of x. So therefore this is proper fraction and we can apply partial fractions method for this. Okay, suppose if we have x cube minus 1 divided by x square plus 1, this is called improper fraction. This is called improper fraction. So what we have to do in this improper fraction? In this improper fraction, we have to convert this for proper fraction. We have to convert this for proper fraction. Clear? How to convert this for proper fraction? That is also question. You have to use long division method. See that x square plus 1 x cube minus 1. So you divide it. You can take here x. So x square into x is x cube plus x. So now I can subtract this. X cube and plus x cube will get cancelled. It will be, take here minus sign. So it will be now minus 1 minus x. Okay. So now you are going to get minus 1 minus x divided by x square plus 1 plus x. Clear? So now you have to do integration of this. Okay. So if you feel any doubt here, you just simplify. X square into x is x cube. 1 into x is x. So x plus x minus x will get cancelled and you will get x cube minus 1. Now you have to do the integration of this term. That is nothing but minus of 1 plus x divided by x square plus 1 plus x with respect to dx. You have to calculate integration of this. Okay. So this is how we have to simplify our improper fractions. Okay. Now you have understood what is proper fraction, what is improper fraction, how to convert improper fraction to proper fraction, and how to simplify the proper fractions will be the big question now. Okay. So for solving the proper fraction, we have to apply some methods of linear repeated roots and linear non-repeated roots, and the third one is quadratic roots. Okay. So these are the three things. So there you have to understand what is linear roots, what is linear non-repeated and linear repeated, and quadratic roots. It is very simple concept. I will explain, don't worry, and by that you can understand how to simplify partial fractions. Okay. So now here you can see the second point, that is the degree of p of x is lesser than or equal to the degree of, lesser than or equal to, not greater than or equal to. The degree of p of x is greater than or equal to the degree of q of x. The degree of q of x, then it is improper fraction. Then it is improper fraction. Okay. So already you have seen one of the improper fraction, that is x cube minus 1 divided by x square plus 1. Now you can also see, suppose if you have x square plus 1 divided by x square plus 2. Okay. So see here, now this is in the form of improper fraction. This is in the form of improper fraction. Clear? So I think now you got an idea of proper fraction as well as improper fraction, and for what fraction we say improper and for what fraction we say proper. I think all of you got a clear idea. Now let us go for the solution of partial fractions. The solution of partial fractions. Here we call as the decomposition. This method is called the decomposition of fractions to the standard form. Okay. So that means, suppose you see the first one, if we have px plus q divided by x minus a into x minus b. So now I have to decompose this. It is decomposed as a divided by x minus a plus b divided by x minus b. Okay. So this is called the decomposition of px plus q divided by x minus a into x minus b. Okay. So if I take one example, I think you can understand that. So I will take the example of your NCERT text. I will take one example of your NCERT text, that is integration of x divided by x minus 1 into x minus 1 into x plus 2 with respect to dx. That is exercise 7.5, exercise 7.5 example 1. This is exercise 7.5 example 1. Okay, so now you just see, we have to simplify this, and you can just see that px plus q divided by x minus a into x minus b can be decomposed as a divided by x minus a plus b divided by x minus b. So this is called your linear non-repeated roots. Please remember here, this is called linear non-repeated roots. Okay, linear non-repeated roots. Clear? Okay, this is called linear non-repeated roots. So for this, let us see how to simplify this for linear non-repeated roots. Okay, so you just see here, first I has to decompose this x divided by x minus 1 into x plus 2. So how can I decompose this? It as a divided by x minus 1 plus b divided by x plus 2. A divided by x minus 1 plus b divided by x plus 2. Okay, no problem. So now you just see, I will take it as x equal to a into x plus 2 and plus b into x minus 1. So to solve the values of a and b, please remember, if you want to find the value of a, you have to make b as 0. If you want to find the value of b, you have to make a as 0. Okay, so for that I can put x equal to minus 2 first, so that minus 2 plus 2 will become 0. So a term will be 0, therefore minus 2 will be equal to b times of minus 2 minus 1. This will be minus 3, so that you can see b is going to be equal to 2 by 3. Okay, this is minus 3. So minus 3 into b is minus 3b. It will be 2 divided by 3. On the same way, you can put x equal to, on the same way you can put x equal to 1, so that b term becomes 0. Therefore 1 equal to a times of 1 plus 2, that is 3. So a will be equal to 1 by 3. A will be equal to 1 by 3. Now we can do the integration of x divided by x minus 1 into x plus 2 with respect to dx. That will be equal to integration of, you can see a value is 1 by 3 divided by x minus 1. So you have to put here a value with respect to dx plus integration of what is b value, 2 by 3 divided by x plus 2 with respect to dx. Okay, so now that will be equal to 1 by 3 log of mod of x minus 1 plus 2 by 3 log of mod of x plus 2 plus c. Okay, so this is going to be the answer for your integration of x divided by x minus 1 into x plus 2 with respect to dx. Okay, so please remember, this is linear non-repeated roots, because you can just see here you have x minus a, here you have x minus b. So x equal to a and x equal to b are going to be the roots where they are not repeated. Okay, so now from this I think you can get an idea of the first method, that is px plus q divided by x minus a into x minus b. Clear? Okay, let us go for the second one. See that I will write the second one as px square plus qx plus r divided by, now I will take 3 non-repeated roots, x minus a into x minus b into x minus c. So my dear students, here also you can see that x minus a, x minus b and x minus 3, x minus c. These are the linear non-repeated roots. Linear non-repeated roots. Okay. So this can be decomposed as a divided by x minus a plus b divided by x minus b plus c divided by x minus c. Okay. That means these are called again linear non-repeated roots. Linear non-repeated roots. Okay. Clear? Okay. No problem. So now here there are 3 roots which are non-repeated. Clear? So for that reason you have to go on solving this. Again you have to decompose. This is called the decomposition. A by x minus a plus b by x minus b plus c by x minus c. Clear? So we can take one example on this. I will take from your NCERT textbook, that is from the exercise 7.5. I will choose example 3. Exercise 7.5 example 3. So that is integration of 3x minus 1 divided by x minus 1 into x minus 2 into x minus 3 with respect to dx. So how can we decompose this? You just see 3x minus 1 divided by x minus 1 into x minus 2 into x minus 3 will be equal to a divided by x minus 1 plus b divided by x minus 2 plus c divided by x minus 3. This is called the decomposition of the partial fraction which is having linear non-repeated roots. Here there are 3 linear non-repeated roots. Okay. So for that I can take this as 3x minus 1 equal to a into, take LCM, that will be x minus 2 into x minus 3 into x minus 1. So here you have already x minus 1 plus b into x minus 1 into x minus 3 plus c into x minus 1 into x minus 2. Okay. Now to take a term you have to make b and c as 0. So for that I will put x equal to 1. If I put x equal to 1, 1 minus 1, b will be 0, 1 minus 1, c will be 0. So that will be 3 minus 1, sorry, 3 into 1 is 3, 3 minus 1 is 2, equal to a into 1 minus 2, 1 minus 3. So that will be 2 equal to 1 minus 2 is minus 1. So minus 1 into minus 2, it will be plus 2. 1 minus 2 is minus 1. 1 minus 3 is minus 2. Minus 2 into minus 1 will be plus 2. Therefore, a will be equal to 1. Next, you can put x equal to 2. So that a will be 0, c will be 0. Okay. Therefore, 3 into 2 is 6. 6 minus 1 is 5. Clear? So, a is 0, c is 0. Now, b into 2 minus 1, 2 minus 3. So, here you can just see 5 into 2 minus 1 is 1. 2 minus 3 is minus 1. So, therefore, b into minus 1. That will be b equal to minus 5. On the same way, put x equal to 3. So, if I put x equal to 3, 3 into 3, 9. 9 minus 1 is 8. So, a will be 0, b will be 0, c into 3 minus 1 into 3 minus 2. So, 3 minus 1 is 2, 3 minus 2 is 1. So, this will be c equal to 4. Okay. So, now you have to use these things for this integration. Put in the value of a. That will be, a value is 1. So, dx divided by x minus 1 plus b value is minus 5. Minus 5, I will take it as constant outside. Dx divided by, it will be x minus 2, x minus 2. And you can see c value is plus 4. Integration of dx divided by x minus 3. X minus 3. Okay. So therefore, what is your answer? Therefore, you can see this will be log of mod of x minus 1. This will be minus 5 log of mod of x minus 2. This will be plus 4 log of mod of x minus 3 plus c. Okay, so this will be your answer. Clear, my dear students? So you understand the concept. Mathematics is such a subject that where you understand the concept, it will be very simple. If you don't understand the concept, then it is going to be very tough. Okay, students. So next we shall go for repeated roots, linear repeated roots. Now we have solved linear non-repeated roots. Next we shall go for linear repeated roots. Okay. So those things are, I will take the form of linear repeated roots. Clear? Okay. So linear repeated roots. Okay, to just see what is linear repeated roots. So now let us go for linear repeated root. Okay, so that is p x square plus q divided by x plus a whole square plus a whole square. Clear? So here you can just see this is linear repeated roots. Okay, a is going to be repeat for 2 times. Now this can be decomposed as a divided by x plus a plus b divided by x plus a whole square. Okay, so px square plus q can be decomposed as a divided by x plus a plus b divided by x plus a whole square. So for this you can just see, I will take one example from our NCERT exercise, that is exercise 7.5 example 14. Example 14. Clear? So for 7.5, that is integration of 3x minus 1 divided by x plus 2 whole square with respect to dx. Okay, so first we have to decompose this, that is 3x minus 1 divided by x plus 2 whole square. We can decompose it as a divided by x plus 2 plus b divided by x plus 2 whole square. Next we have to find the values of a and b. To just see, I take it as 3x minus 1 equal to a into x plus 2 plus b. I think everyone knows to solve this by taking LCM, no problem. Now I will put x equal to minus 2, so that a will get cancelled, I will get b value. 3 into minus 2 is minus 6 minus 1. This is b. That means b is equal to minus 7. B is equal to minus 7. B is equal to minus 7. Clear? So now let us find b. So to find b, let us compare LHS and RHS. So that, sorry, now we have to find a value. Okay. So to find a value, you can take x value as 0, no problem. You take x value as 0. So that will be minus 1 equal to 2 times of a, and you know that b value is minus 7. So minus 7, if I take it on this side, it will be plus 7. Minus 1 is 6 by 2 equal to a. So a will be equal to 3. Okay. Now we can simplify this as integration of a value is how much? 3 divided by x plus 2 with respect to dx, and here plus integration of b value is minus 7 divided by x plus 2 whole square with respect to dx. So that will be 3 times of log of mod of x plus 2, and this is minus 7, it is constant. Now you have to solve integration of dx divided by x plus 2 whole square. So that will be minus 1 by x plus 2, minus 1 by x plus 2, because you may have seen that the integration of 1 by f of x to the power of n is equal to minus 1 divided by n minus 1 into f of x to the power of n minus 1. I think you know this formula. So from that we can apply that formula and we can get the answer into, this will be minus 1 divided by x plus 2. Minus into minus will be plus 7 by x plus 2 plus c. So this is your answer for this particular question. Okay. So very simple. Now we can go for the another form of partial fraction, that is your again linear repeated roots. Again your linear repeated roots with quadratic form. Okay. So let us solve one more problem of that kind, so that you will get the complete idea of all the partial fractions. Okay. So you see the fourth one, that is px square plus qx plus r divided by x minus a, and this is x square plus bx plus c, x square plus bx plus c. Okay. So my dear students, here you can say that, sir, I can write this by solving fractions. But my dear students, please listen, x square plus bx plus c will be such simplest form, there you can't further factorize it. So that kind of situation. Okay. So now if I decompose this, you can see here, this is quadratic root, not linear root. This is quadratic root. Previously this is linear repeated, and previously you can see this is linear non-repeated. Okay. So therefore for this quadratic roots, you can just see, to decompose this, I will write it as a divided by x minus a plus bx plus c divided by x square plus bx plus c. So now we can take one exercise problem. To just see from exercise 7.5, I am choosing the problem number 13. That is integration of 2 divided by 1 minus x into 1 plus x square with respect to dx. Clear? So now this will be equal to, okay, first we shall decompose it. 2 divided by 1 minus x into 1 plus x square. This will be equal to a divided by 1 minus x plus bx plus c divided by 1 plus x square. Now let us simplify this. It will be 2 equal to a into 1 plus x square plus bx plus c into 1 minus x. Okay. So now for this I can put x equal to 1. So this term becomes 0. Therefore 2 equal to a into 1 plus 1 is 2. Therefore a value will be 1. 2 by 2 will be 1. Next put x equal to 0. So if I put x equal to 0, here you are going to get 2 equal to a, b into 0 is 0 plus c, 1 minus 0 is 1. So it will be a plus c. Therefore you can see a value is how much? 1. So therefore c equal to minus 1. Clear? So now from this, if you want to find C term, you can compare the coefficient of x, because C into x will be minus Cx. So compare coefficients of C. So that will be sorry, not C, x, coefficients of x. So that means here there is no x value, so you take it as 0. Again, a into 1 is a into x square will be ax square, so there is no use. Bx into 1 is bx, so therefore b I can take. C into minus x is minus. Okay, so you can see C value is minus 1, therefore b minus of minus 1, therefore b will be equal to minus into minus is plus, you take it on this side, minus 1. Okay, so you get a value as 1, b value as minus 1, and C value as, you can just check C value as, a value is how much? A value is 1. So if you take 1 on this side, it will be 2 minus 1. So 2 minus 1 is plus 1. Sorry, C value is plus 1. Okay, C value is plus 1. On the same way, you can take plus 1 here. Sorry for that. So minus 1 into plus 1 is minus 1. If you take minus 1 on this side, it will be plus 1. So here, sorry for this, because a value will be what? A value will be 1. So 1 if I take on this side, 2 minus 1 will be 1. Clear? So no problem. Now you can just go and simplify this. That will be integration of a value is 1 dx divided by 1 minus x plus integration of b value is 1. So that will be x plus c value is 1 divided by 1 plus x square with respect to dx. So therefore you can just see it, integration of 1 by 1 minus x is log of mod of 1 minus x divided by minus 1 plus, so here you can write it as integration of x divided by 1 plus x square and plus integration of dx divided by 1 plus x square. You will get this term is tan inverse x, and this term you can just see it will be 1 by 2 into log of mod of 1 plus x square plus c. Okay, so this is going to be your answer. Clear? Okay student, so this is your answer for problem number 4. Okay, so we lost a little bit concentration here. Don't lose any concentrations, because problems are going to be very interesting, and there sometimes you may lose concentration and you can miss plus and negative sign, but don't worry. So now you got the right answer. Okay students, so now we got the answer, that is minus log of mod of 1 minus x plus tan inverse x plus 1 by 2 log of mod of 1 plus x square plus, this will be your answer. Okay, so this is all about your partial fractions. I think all of you have understood this. In the next class, I will come up with the tricks to solve this algebraic equations, nothing but your partial fractions. So there are some tricks which you can use for your competitive exams. So because you have to understand the concept, these things are very essential. So you try to solve exercise 7.5, NCERT exercise 7.5. Once you understand that, then next we can go for the tricks and quick methods what we can apply for our partial fractions. So in the next video I will come for that. So quickly all of you comment in the comment box which type of problems you need, any doubts that you have. So if you have any confusions, you can put in the comment box. So I will see that comments and I can reply for you in the next class. Clear? So thank you everyone. Be with the JEE Maths Mantra. Subscribe the channel, click the bell icon so that we can always be up to the mark with every concepts of mathematics. Okay, thank you.